right now. Okay. So, this chapter is all about normal distributions. So, we've done a lot of probability stuff. Chapter 3 was probability about like finding the probability of and or problems, that kind of stuff. Chapter 4 was all about discrete probabilities. That was stuff that we can calculate. And this is more about continuous probabilities. So do you guys remember the difference between discrete and continuous? Discrete is countable, continuous isn't, right? So this would be a great example of like how you would show people's heights, people's weights, a lot of stuff about people that is natural, where most of the people would be in the middle. Then you got some people, like if we're talking about weight, you've got an average here for most people, and then you've got some people who are extremely skinny and some people who are extremely heavy, and so on. Okay, same thing with heights, same thing with pretty much anything you can measure about humans that comes naturally. Measurable things, that's what this is about. This is called a normal distribution. So a bell curve is the same thing as a normal distribution. We've already talked about the empirical rule, right? Like what percent is between like one standard deviation and what percent is between two standard deviations and so on. Thank you. You guys want a copy of this now? You can just not have your book open, and you can not have to, sometimes it's nice to be able to write on these, and I prefer if you didn't write in your book. Does anybody find that somebody's already written in their book on this chart? It happens a lot. Okay, I made a whole bunch of these, so if you run out, there's extra copies. Okay, so the middle is mu. We already knew that from the empirical rule. We've got mu plus sigma on one side, mu plus 2 sigmas, mu plus 3 sigmas. That's one standard deviation away, 2 standard deviations away. You remember this stuff? Yeah? All right, so let's talk about the rules. Rule number 1. The mean, median, and mode are all equal. On a bell curve, the mean, median, and the mode are all in the middle because it's exactly symmetric. Normal curve is bell-shaped, is symmetric about the mean. Total area under the normal curve is equal to 1. That means 100% of the probability is underneath the bell curve. The normal curve approaches but never touches the x-axis. So basically, remember this keeps coming down further and further and further. It gets closer and closer and closer and closer, but it never quite touches it. That means you could have a weird outlier like clear out here or clear out here, or way out there, right? Somebody who's very odd, that doesn't mean that they're a liar. I had a kid, did I tell you about that? I had a kid ask me once what if they're not lying? And I was like, that's not where liar comes in an outlier. It means it lies outside the mean. Inflection points. Have you ever heard of inflection points? What these are is it's where it changes from like concave down to concave up. The difference between concave down and concave up is something you got to know in calculus. Do you see how this part above these 2 points looks like it's kind of face down, like an upside down U, right? Or an N. And then below it, if you look at the curve, it looks more like it's curved up like a cup. Okay, so concave up is like a cup, concave down is like you're throwing whatever your drink you have on the ground, and that's where it changes it. If you, this is the fun part of a water slide. Have you ever been on a water slide where like you start at the top, right, and then you go faster and faster and faster and faster, and then you hit that point where you're almost in free fall, and then like the slide catches you and slows you down? Do you know what I'm talking about? That is an inflection point. That is what they're trying for. They actually make it so the slide goes from concave down to concave up. And right there is that point where you feel like you're in free fall because technically this slope turns out to be infinite right there. So that's what makes that drop in your belly and what they try for on amusement park rides. Okay, now we know that like from here to here, do you guys remember what percent that is? It's 34 from here to here, so but from -1 to +1 would be like 68%. You remember this, the empirical rule? Do you remember what the next one is? Yeah, 13.5, 13.5, which adds up to 95% across the whole thing. And then these ones right here end up being, I think it was 99.7%. And then you've got 0.3% in the little tails on the edges. That's the empirical rule. But then, of course, the question becomes, what if you're not 1 standard deviation away from the mean? What if you're not 2? What if you're not 3? What if you're 1.5? What if you're 1.75? What if you're negative 2.14? The way you find the area under a curve is calculus. That's the main function of calculus, is to find areas or functions underneath curves. Curves describe how things are moving, which helps a lot as far as looking at stuff like cell phone data waves, but also like speeds of things and so on, like how your car works. But also it's really helpful just to find the area underneath a curve just for manufacturing. So somebody did it for us. If you look at in your book, page A16 or page A17, you'll see that this is all the calculus that they did, and it's like a reference sheet that you get to use. I had a kid ask me once, do they have to memorize this sheet for the AP test? No, they give you one. Okay, I promise. There's no reason to ever memorize this. What if you had to memorize this, I would tell the school that I didn't want to teach this course and that I would just teach calculus from here on out, because nobody would pass it. Like, why would anybody ever try this? It's stupid, but you do have to know how to read it. On this side is all of the negative. This is, if you want to write on the A16 side, this is the negative scores. That's on the left side. The negative z-scores on the left. And A17 is the positive side. Do you guys remember the formula for a z-score? X minus mu over sigma. We'll be using that a lot this chapter. Remember, x is your data point, mu is the mean, and sigma is the standard deviation. But this lesson is only about figuring out how to read this table. That's all this is, okay? The thing you need to know is that the table always reads to the left. So if you're trying to figure out what's happening on the other side, or what's happening on the right side, then, and both of these read to the left, just in case you're confused, then you'd have to take 1 minus that.